Hey guys, welcome back everybody. Hope you all are doing great. Guys, this is part 3 of this network topology configuration, and today we will see some additional configurations on ASA Firewall, like configuring primary and secondary scenario. As you can see, my ASA Firewall is connected with two different ISP, ISP1 and ISP2. What it mean? It means that my end users can access internet either via ISP1 or via ISP2. It's totally depends on the configuration on ASA firewall, that how ASA firewall is going to treat the traffic, how ASA firewall is going to forward traffic to internet. So on the ASA firewall, actually I have two way to forward traffic to internet. Either I can forward via ISP1 or via ISP2. So today in this video we are going to configure ASA firewall in such a way so that it will forward all internal traffic to internet via ISP1 if ISP1 is available, if ISP1 is up. So guys, your scenario is like these all end devices and machines, all departments should be able to access internet via ISP1 if ISP1 is up. Let's suppose here I have 8 Mbps link, right? And here I have only 2 Mbps link. So this is my primary ISP, this is my secondary backup ISP. So I need to configure primary and secondary on ASA firewall so that my end users can access internet through primary ISP. But in case if primary ISP is not available, then my end devices can access internet via secondary ISP, via ISP number 2. So how you will configure the ASA firewall to achieve this scenario? Okay, so guys, actually I have to configure this firewall in such a way so that this firewall will be keep tracking ISP1. It will be keep tracking ISP1, that if ISP1 is up, then it will forward traffic to ISP1, but if ISP1 is down, then it will shift all traffic towards ISP2 automatically. So ASA firewall need to track ISP1. So we are going to configure track today in this video, track. And guys, to track the ISP, we have to configure SLA, IP SLA. So we'll see IP SLA configuration here, right? Maybe we will ping to 8.8.8. See, either ASA firewall can track this IP address 8.8.8. If 8.8.8 is reachable via ISP number 1, then forward all internal traffic towards ISP 1. But if this 8.8.8 is not reachable from you, then forward all traffic via ISP number 2. So either I can track 8.8.8 or I can track this ISP router IP address, which is 1.1.1.6.6. So either you can track this IP address or you can track 8.8.8. And after that, guys, you are going to configure again NAT for translation. So today in this video, we are going to configure three things: track, IP SLA, and NAT on ASA firewall. And guys, all access layer switches are pre-configured, like we are running RSTP protocol, we are running VTP protocol here, DTP protocol here, right? Link between switches are trunk with the help of DTP protocol. Then we have enabled port fast on all access port. Then we have configure ports for data VLAN and voice VLAN, data VLAN, voice VLAN, right? And port security, right? We are allowing only 2 MAC addresses on each access port. Then we have configured the MAC aging time, right? Means MAC address table. So these all access layer switches are pre-configured. All distribution layer switches are also pre-configured. Here we are running HSRP protocol for load balancing. We are performing load balancing in this scenario between distribution layer switch 1 and distribution layer switch 2, because distribution layer switch 1 is my active switch for VLAN 10 and 20, and distribution layer switch 2 is my active switch for VLAN 30 and 40. I have 4 VLAN in this scenario. You can see data VLAN, voice VLAN, HR VLAN, and server VLAN. Then guys, we are running OSPF routing protocol in this domain for the internal routing, OSPF area 0, right? OSPF 1 area 0 for the internal routing. And on distribution layer switches, I have some SVIs interface for VLAN 10, 20, 30, 40, right? And last IP address from the subnet is configured on distribution layer switch 1, and second last IP address from the subnet is configured on distribution layer switch 2 for all VLANs. And guys, virtual IP address is the gateway IP address, which is .100. You can see 192.168.1.100 for VLAN 10, 2.100 for VLAN 20. Even distribution layer switch 1 is acting as DHCP server. This is my DHCP server, which is responsible to provide IP address, default gateway, and DNS server IP addresses to the client machines, right? So let me verify that client machines are able to get IP address from DHCP server or not. So I'm going to access let's say PC1, and guys, on PC1 let me say IP DHCP, and you can see DORA process is working. That means DHCP is working fine, and this machine have got one IP address, that is 192.168.1.1, correct IP address from the correct subnet. And guys, default gateway is the virtual IP address, which is .100, right? So if you have not watched, if you didn't watch my first two video of this topology, then guys, please watch day 1 and day 2, part 1 and part 2 video first. After that, watch this video, then only you can get. And now let me check HSRP is working fine or not. Means, am I able to ping virtual IP address, which is my default gateway? So yes, you can see I am getting reply. That means I am able to ping my gateway. Fine. In the same way, you can access PC2 also, which is a part of VLAN 20. So let me check VLAN 20 users are able to get IP from DHCP server or not. So you can see VLAN 20 users are also able to get IP address. And guys, IP address is correct from the correct subnet 192.168.2.1. You can see for VLAN 10, my subnet is 192.168.1.0. For VLAN 20, 2.0, for VLAN 30, 3.0, and for VLAN 44.0. So all machines are able to get correct IP address, and their gateway IP address is 192.168.2.100. So VLAN 20 users will get this IP address as default gateway, and let me ping to their default gateway 192.168.2.100. So you can see VLAN 20 users are also able to ping their gateway, right? And guys, for VLAN 10 and 20, distribution layer switch 1 is the gateway, right? Active switch in HSRP. If you want to verify it, simply you can access distribution layer switch 1, and here you can run command so standby. So standby, let's say for VLAN 10. So you can see for VLAN 10, this switch is active switch. State is active because priority is 110. Preemption is enabled. In the same way, for VLAN 20, see, this switch is the active switch for VLAN 20 also, right? Virtual IP address 2.100 for VLAN 20. But for VLAN 30, you can see this switch is a standby switch. Distribution layer switch 2 is the gateway, active switch, right? So virtual IP address is this one. So if you want to verify VLAN 30 also, so you can access any PC which is in VLAN 30. Like you can see in VLAN 30, I have some servers. So let me access server 1 here, and I am going to, so I think servers are in VLAN 40. I need to correct it. This is, it will get IP from 4.0. Servers are in VLAN 40, I think. Let me check. Yes, you can see 4.1 is the IP address. Gateway is 4.100 and ping 192.168.4.100. So I am able to ping my gateway, right? So server is also able to ping their gateway, which is part of VLAN 40. That means HSRP is working fine, right? We don't need to configure anything on access layer switches, on distribution layer switches, even on core layer router. See guys, on core layer router, you are running OSPF protocol. So IP OSPF interface brief. So you can see OSPF is enabled on all physical interfaces. And so IP OSPF neighbor. And guys, we have 3 neighbors on core router. 2.2.2 means distribution layer switch 2, 1.1.1 means distribution layer switch 1, and 4.4.4 means my ASA firewall. And so IP route OSPF. So you can see this core layer router is learning all internal prefixes through OSPF, correct? And guys, so IP route 0.0.0, or I can say include 0.0.0, but we don't have any default route here. So either I can advertise one default route from ASA firewall, or I can configure one ASA default route here, and then I can advertise that default route in OSPF domain. Right, leave it for now, we'll do it later. Now let me access ASA firewall. Now guys, on ASA firewall, if you want to verify the configuration, so you can check so interface IP brief. So you can see all physical interfaces are already configured, right? On 0/0, which is connected with ISP1, IP address is 1.1.1.1. On G0/1, which is connected with ISP2, IP address is 2.2.2.1, right? On the inside interface, which is connected with core router, IP address is 192.168.0.2. If you want to see the running configuration, so run interface G0/0. So guys, name if of this interface is outside ISP, outside underscore ISP1. Subnet mask is 255.255.248 means /29. Security level is 0 because this is my outside interface. In the same way, you can verify configuration on 0/1 interface also. So here you can see name if is outside underscore ISP2. Description connected to ISP2. Security level here is 0 and IP address is 2.2.2.1. Submit mask 255.255.255.248. Right? In the same way, 0/2. So guys, on 0/2 description you can see connected to core router and name if inside. So name if of this interface is inside because of this security level is 100 over here and IP address is 192.168.0.2, right? My private IP address. So on my inside interface, I have private IP address. On my outside interfaces, I have public IP addresses. Now let me check default route. So route include 0.0.0. So guys, I don't have any default route here. So run route. See, I don't have any default route configuration in the running configuration. So route OSPF. So route OSPF. But this ASA firewall is learning all internal prefixes with the help of OSPF protocol, right? So ASA have all internal prefixes, means it can forward traffic to VLAN 10, 20, 30, 40, right? This is prefix for VLAN 10, for VLAN 20, for VLAN 30, and for VLAN 40. So ASA firewall have route for each subnets. Done. Now here on the ASA firewall, I should verify the connectivity. Am I able to ping ISP router 1.1.1.6, which is the IP address of ISP1 router? So yes, you can see ISP1 is reachable from ASA firewall. Then ISP2 2.2.2.6. Yes, ISP2 is also reachable from ASA firewall. Now can I ping 8.8.8? Ping 8.8.8.8? No, I am not able to ping 8.8.8 because default route is not available, right? Route is not there for 8.8.8 in the routing table. So when you are pinging to 8.8.8, ASA is going to compare it with their routing table. So route, and guys, in their routing table you can see no route available for 8.8.8. So ASA firewall is going to drop the packet. Now before configuring the default route, as I told you, today we are going to configure primary and secondary. So we are going to create SLA. Okay, so guys, let me create one SLA over here to track 1.1.1.6. let's say I am going to track ISP1, right? So if I want to track ISP1, I have two options. Either I can track 8.8.8 or I can track internet router IP address, which is 1.1.1.6. So I'm going to track, let's say 1.1.6. So say SLA monitor, and after that number, right? So number is, let's suppose 10. SLA number is 10. Fine guys, now I am going to say type, and I'm going to send echo message, echo, and after that protocol I'm going to use IP ICMP protocol, and then IP address. To which IP address you are going to ping? You are going to send ICMP echo request message to 1.1.1.6, right? And then from which interface? From interface, and guys, name if of outside interface which is connected with ISP1 is outside ISP1, right? So this is my command. This is my command. Type echo protocol IP ICMP and then the IP address, and after that interface, from which interface I am going to send ICMP echo message. Now I need to schedule this IP SLA, and before that, if you want to configure the frequency, timeout, threshold, you can configure those all things here, right? So again, go to SLA monitor 10, and here you can say frequency. Let's say frequency is 1. After 1 second it is going to send ICMP request message, but you cannot configure frequency less than timeout. So let me define timeout 500 second or 100 second, right? Timeout is in millisecond, right? This is in millisecond. And now guys, frequency is, let's say 2, and you can configure the threshold also. You can configure number of packet also, that how many packet it will send. But ignore these things for now, because we are not talking about IP SLA, just we are implementing it on ASA Firewall. Now I need to schedule this SLA. See, till now my ASA is not going to forward any ICMP echo message. Debug ICMP trace. You can see ASA Firewall is not sending any ICMP echo message because till now we didn't schedule it. We have created it. You can see so run SLA monitor. So this is my configuration. Monitor number 10, SLA monitor number 10, and this is my command, right? Timeout is 100 millisecond, frequency is 2 seconds, but I didn't schedule it. So guys, to schedule this SLA, say SLA monitor number 10, not 10, schedule, yeah, schedule, and after that number, SLA number 10, and life, let's say life is forever, right? I want to track it for forever. And when you want to start it, I want to start it right now. Say start time now. So SLA monitor schedule 10. So I am scheduling SLA number 10, and life is forever, and start time is now. Once I will hit enter, you can see that my machine is sending ICMP echo request message, right? And it is getting reply as well, reply message. Why it is sending frequently, guys? Because frequency is 2 seconds. So after 2 seconds, it is sending one echo message, right? If you want to increase the frequency, simply first say on all, and I'm going to remove this command, schedule command, because if your SLA is scheduled, then you cannot modify your SLA. See, if I will try to modify my SLA, so run SLA monitor, right? So I'm going to modify my SLA. See what it's saying, entry already running and can't be modified. So if SLA is scheduled, then you cannot modify it. So if you want to modify it, first of all you have to stop the schedule, right? So say no SLA monitor schedule 10 live forever start now. I have removed this command. Now I can modify my SLA. Here I am going to say frequency 10 second, right? Now again I am going to schedule the SLA. Let me run this command again. SLA monitor schedule 10 live forever start time now. Now my ASA firewall is going to send ICMP echo request message after every 10 second, right? So just wait for some time. After 10 seconds you will see your ASA firewall is going to send one ICMP request message, right? And you can verify it by running command show SLA monitor and then operational status. So you can see timeout occur is false, right? So if ASA will not get reply, then timeout occur will become true, right? So now my IP address is reachable from ASA firewall, that's why timeout occur is false, right? Till now timeout is not occurred, right? Till now timeout is not occurred. And guys, if you want to see the configuration, you can see here entry number is 10, modification time, last modification time, number of operation attempted 4. It have sent 4 ICMP message, echo message. Skipped, operation skipped is 0. Current second left in the life is forever, operation state active, right? Connection loss occur false, timeout occur false, over threshold current false, and RTT 20 second. Okay, but frequency is 10 second right now. So let me debug again, debug ICMP trace. So you will see your ASA firewall will send one ICMP echo request message after every 10 second to 1.1.1.6, right? See, it is sending, and this ASA firewall is getting reply as well, right? But guys, if you will down the ISP1, then what will happen? If you will down the ISP1, let me access ISP1 and let me down it. Enable config T interface F0/0. Let me verify the interface. Yes, F0/0 on the internet router. I'm going to run shutdown command here. So if I will run shutdown command on ISP, that means my ASA firewall will not get reply message. So wait for next ICMP echo request message, and after that here you can run command C. It have sent one ICMP echo message, but ASA firewall didn't receive any reply this time. So if ASA firewall is not going to receive reply, then timeout occur will become true. So SLA monitor operational state, you can see timeout occur true. Okay, now again when I will up it, when I will up the interface, ISP interface, what will happen? Again it will, my ASA firewall is going to receive echo reply message, and again operational timeout will become false, right? So see the echo request message, soon it is going to receive reply message. Wait for some time, this is in simulation, that's why it's taking some time, right? So see the reply message. Now ASA firewall have received the reply message. So now again you can check so SLA monitor operational state. Now you can see timeout occurred false, right? And guys, one more command is there to verify the configuration, that is so. First of all, let me disable the debugging, say on all, and I can run so SLA monitor and then configuration. right? So you can verify the configuration by running this command, right? So these are verification command. You can see the target IP address is 1.1.1.6. Type of op operation to perform is echo, ICMP echo request message. Interface is outside ISP1. This is name if of my outside interface which is connected with ISP1. And guys, how many number of ICMP packet my ASA firewall is sending? 1. Then request size, operation timeout 100 millisecond. So you can verify this all configuration. Frequency, group schedule, live, is out, status. Done. So right now ISP is up. That's why you can see on ASA firewall my timeout is false. But if ISP will goes down, timeout will become true. Done. So this is SLA, or you have this command also. You can verify configuration by running so run, and then I can say SLA monitor to check commands, whatever commands you have enabled. So you can see this command, this command, this command, and this command. So this is all about SLA configuration. Now I have configured the SLA, I have scheduled the SLA. Now I am going to create one track, right? So let me say track, and after that guys, object number, track object number is, let's say 10, right? Or you can say 1 or 1 2 3, any number, right? Let's suppose 10. And then response time reporter SLA. Let me call to SLA. Which SLA? SLA group number, SLA number 10, SLA monitor number 10. So let me call to 10 and then say reachability. That's it. So if you will check your track now, do so, not do, so track. So you can see your track is up. Why your track is up? Because the target IP address is reachable from here. So SLA monitor, and I can say so SLA monitor operational state. So you can see timeout is false, right? That means my target IP address is reachable. That's why track is up. But if ISP will goes down, let me run shutdown command here and debug ICMP trace. So now my ASA firewall is not going to receive reply message, right? So wait for some time. ASA firewall is going to send ICMP echo request message. You can see ASA firewall has sent one ICMP request message to 1.1.1.6. From which interface? From 1.1.1.1, right? But ASA didn't receive reply message. So you can check. So SLA monitor operational state timeout occur is true, and if timeout occur is true, then your track is down. So track, you can see your track is down. Now my track is working fine. If ISP1 will come up, when ISP1 will come up, again my track will come up, right? Because ASA firewall is going to receive reply from 1.1.6. So wait for some time. ASA firewall will again send one ICMP request message. Yes, you can see. And this time ASA firewall will receive reply message, right? See the reply message. Once it will receive the reply, so SLA monitor operational state, you can see timeout occur will become false and my track will come up. So track, now my track is again what? Up, right? So hope SLA and track is clear to you how it is working on ASA firewall. Now guys, I am going to configure default route on ASA firewall, right, with the help of track. So let me disable debugging and say route and after that interface. So outside ISP1 is my primary ISP, right? This is name if of 0/0, which is connected with primary ISP. Then say any network 0.0.0, any subnet mask 0.0.0, and next hop IP address 1.1.1.6. And I am going to call track with this default route. So track number is, I think track number is 10. Let me verify it first. So run track. Yes, track number is 10. So I am going to call this track with this default route outside ISP1 0.0.0, 0.0.0, 1.1.6, and track 10. So this default route will be in the routing table until and unless track is up. So right now guys, my track is up. My track is up. So you can check the routing table. So route include 0.0.0. So that's why you can see default route is there in the routing table. But if track will goes down, again let me debug ICMP on the ASA Firewall. Guys, these are important things and we are using it in real time. That's why I'm going very slowly today in this video. Okay, again I'm going to down ISP1. So what will happen when you will down ISP1? When ISP1 will goes down, here track will goes down. First what will happen? IP SLA will not receive reply message, so their timeout will become true. So you can run command show SLA monitor, and these all commands you will use to troubleshoot, to verify the configuration. While troubleshooting, you are going to check that timeout occur is true or false, right? Track is up or down. So you can see, as I am not getting reply message, my timeout occur become true. So if this is true, then my track is going to be down. So you can see track is down. And now so route include 0.0.0. If track is down, then ASA is going to remove that default route in their routing table. Now guys, what I want, if track is down, then ASA Firewall should forward traffic towards ISP 2. If track is down, then ASA Firewall should forward traffic towards ISP 2. So now I need to configure one default route here on all. So right now I don't have any default route in the routing table. Reason, track is down. So when track will be down, that time I need one default route. This one, default route outside ISP 2. Name if of my G0/1, which is connected with ISP 2. So this time I am configuring default route on 0/1 interface. Any network 0.0.0, any subnet mask 0.0.0, next hop IP 2.2.2.6, and here I am going to set one AD value, higher AD value, let's say what, 10. Done. Now you can check show route. See, in the routing table we have one default route towards ISP 2. Why we have default route towards ISP 2 guys? Because my track is down. See, in the running configuration I have two default routes. So run route, I have two default route. One is towards ISP 1 with track number 10, and another default route is without track with AD value 10. This route is with AD value 1, default AD value, right? So in the running configuration I have two default route, but in the routing table I have one default route towards ISP 2. Reason, my track is down, means ISP 1 is down. But what will happen if ISP 1 will come up? Let me say no shut on the ISP interface, no shut, and here I am going to enable debugging, debug ICMP trace. So again ASA Firewall will receive reply message this time, right? See, it have sent one echo message. It has sent one echo message to 1.1.1.6 from 1.1.1, and it have received the reply message. So it have received the reply message. That means so SLA monitor operational state. So timeout become false. So my track will come up. You can see track is up, and if track is up, then ASA is going to install which route in the routing table? So route include 0.0.0 via ISP1. You can see now default route is on outside ISP1 interface, which is connected with ISP1, right? Say on all here. Okay, so route include 0.0.0. Done. So can I ping 8.8.8? Yes, I can ping 8.8.8. See, ping is working. And if you will trace route 8.8.8, trace route 8.8.8.8, say numeric. So you can see next hop IP address is 1.1.1.6, right? Means 8.8.8 is reachable via ISP1. But guys, if ISP1 bill goes down, again let me shut it. Let me shut down the ISP1 and let me again debug ICMP trace. So SLA, so you can see this time ASA Firewall is not getting reply message. So SLA monitor operational state. You can see timeout became true, and when timeout became true, track will goes down. So track is down, and when track will goes down, it will install which route in the routing table? So route include 0.0.0 via ISP2, right? So can I ping 8.8.8 now? Yes, I can ping 8.8.8. What? Via ISP2, right? On all. Trace route 8.8.8.8. You can see 8.8.8 is reachable via 2.2.2.6 this time, right? But again, if ISP1 will come up, again ISP1 is up, debug ICMP trace, it will get reply message. So SLA monitor operational state, you can see, just wait for some time. Now you can see it have received the reply message. So you can see timeout occur false. So track, so my track is now up, and so route include 0.0.0. So that's why default route is reachable via ISP1, right? So again, if you will trace route, you can see it is reachable via ISP1. Hope now it is clear. Hope SLA is now clear to you. And guys, SLA is working fine on ASA Firewall. Track is working fine, SLA is working fine, default route is working fine. If ISP1 is up, then ASA Firewall is forwarding traffic to ISP1. But if ISP1 is down, then ASA Firewall is forwarding traffic to ISP2. Now guys, we need to configure NAT over here so that my end users can access internet. And you know, to implement NAT, again I have lots of options. Like I have multiple types of NAT: static NAT, dynamic NAT, static PAT, dynamic PAT. And for the implementation also I have multiple options like auto NAT, manual NAT. So in this series maybe I will upload 5 to 6 videos, because in next video we will talk on the NAT, like how many options I have to implement NAT. Because see, I need to configure a static NAT also on ASA Firewall, 1-to-1 NAT, so that outside user can access my server. You can see in my internal network there are 2 server guys. So I want outside users on the internet. This is, let's say, internet connected with both ISP, and on the internet there are lots of users. So I want these users should be able to access my internal server with the help of public IP address. So I need to configure bidirectional NAT on ASA Firewall, right? And a static NAT is bidirectional NAT, 1-to-1 NAT. But for today in this video we are not going to talk about NAT, right? This is for SLA, to configure primary and secondary scenario. So I am going to implement a simple NAT here. I'm going to create one object network, and let's say my inside network. Here I can match the subnet, let's say 192.168.0.0, right? Or you can say 0.0.0 means any subnet on the inside interface, and here I am going to say NAT inside outside ISP1 and dynamic interface. This is PAT configuration done. Now my ASA firewall can perform translation. Let me check and users are able to ping internet. So let me take you to PC1. See, PC1 is able to ping their default gateway. Can PC1 ping to 8.8.8 internet? Let me try ping 8.8.8.8. See, ping is not working. Destination host unreachable. Guys, if I am getting this error, destination host unreachable, that means my default gateway don't have route, right? So distribution layer switch 1 is the default gateway. That means distribution layer switch 1 don't have route for 8.8.8. Yes, you can check the routing table. So IP route. Here I have one default route via 192.168.0.6 through core router, and on core router let me check default route. So IP route include 0.0.0. So here I don't have any default route. So route, you can see I don't have any default route here, but we are advertising one default route in OSPF. So run section OSPF, you can see default information originate always. Even I have one filtering here, so let me remove this filtering. Config T router OSPF 1 and say no to this command, right? So if you will remove default information originate command from here, default information originate always, say no to this command. Now your default gateway means distribution layer switch 1 don't have default route. See here again, clear IP route star, and so IP route. This is error. So IP route OSPF, actually on the core router I think do so run section OSPF, default information originate command is not there. Now clear IP OSPF process, and so IP route OSPF. It is still learning one default route on 1/0 means from the core router. Guys, this is error, right? But here I need to configure this command default information originate always, so that my core router is going to generate one default route towards distribution layer, and I need to configure one default route here, IP route 0.0.0 towards ASA firewall. I need to configure one default route because right now my core layer router don't have route for 8.8.8. So IP route 0.0.0 any subnet mask, and next hop IP 192.168.0.2, right? Even you can define exit interface as well. Now let me save the configuration, and now let me try to ping 8.8.8. So go to PC1 and let me ping 8.8.8 again. So you can see this time I am getting timeout error. Now what is the issue? Why I am not able to ping 8.8.8? Let me do one thing. Let me check ASA firewall, that ASA firewall is translating source or not. Debug NAT 255, let's say, and now I am going to ping again 8.8.8. So you can see ASA firewall is translating, guys, right? So when it is receiving traffic on, just wait. See, local 192.160.1.1 is the IP address of PC1. right? Source IP, destination IP 8.8. My god, 8.8.8.8. What is happening? On all. I've disabled the debugging. Now let me show you the translation here. See, source 192.168.1.1, destination 8.8.8.8, and ASA Firewall have translated the source into 1.1.1.1 from this pool, from this public IP to this public IP address, right? So NAT translation 192.168.1.1 is translated into 1.1.1.1, right? And destination IP is 8.8.8.8. I think it is not translating reply message, but yes, it is translating reply message. Also, you can see the reply ICMP echo reply message. Local locate untranslate source 8.8.8, destination 1.1.1.1, and it is translating 1.1.1.1 to 192.168.1.1, right? So this is untranslation and this is translation. This is NAT translation to the request message, and guys, this is untranslation to the reply message. So NAT is working fine on ASA Firewall. Even you can check. So NAT pool here. So NAT translated, and then I can say interface outside ISP1. On this interface you can see translated hit, translate hits 10, untranslate hits 10. That means I have pinged 8 ICMP packet, sorry, 10 ICMP packet, right? 5 here, 5 here. So that's why ASA Firewall has translated 10 times source and 10 times it have untranslated, right? So NAT is working fine, then why I am not able to ping? So reason, guys, by default ICMP packet is not inspected on ASA Firewall. So if you don't know about ASA Firewall, then you can watch my ASA Firewall playlist on YouTube, right? Complete playlist is available on the YouTube channel, right? You can learn more about ASA Firewall by watching those video. So guys, here I need to inspect ICMP protocol. So simply I will run command fix up protocol ICMP, and now I am expecting that end users can ping to 8.8.8, and you can see ping is working. Now PC1 is able to ping 8.8.8. Can VLAN 20 user ping to 8.8.8? Let me try. Go to PC2 and ping 8.8.8.8. Yes, you can see PC2 is also able to ping internet. Can server ping to internet? Where is server? Let me access the server one, and let me define the IP here. IP DHCP. Servers are in VLAN 40, so it will get IP from 192.168.4.0 subnet. 4.1 is the IP address, right? Ping 8.8.8.8. And guys, see, ping is working, means my all end users are able to access internet. So guys, today in this video we understood how we can configure primary and secondary ISP on ASA Firewall. So my ASA Firewall is keep tracking ISP1, right? You can debug ICMP protocol, debug ICMP trace to verify that it is sending ICMP message continuously or not, right? So it will show you ICMP request message after some time, right? After the defined frequency. So you can see it have sent one ICMP packet and it have received the reply message as well. So if it is receiving the reply message, that means your track is up. If your track is up, that means default route is reachable via ISP1, right? If ASA Firewall is not receiving reply message, that means your track is down, and if your track is down, then ASA Firewall is going to install default route via ISP2. Done. You can see it is getting reply message, so say on all. That's all for today, guys. In next video we will see maybe NAT configuration on ASA Firewall, or how we can enhance the configuration. See, many more configurations are there in this scenario that we will see in upcoming days, in upcoming videos. Like there are some unwanted prefixes on ASA firewall, or let's suppose ASA firewall is not for routing, so I don't want to install all internal prefixes, so route OSPF these prefixes in the routing table of ASA firewall. So what I can do, I can configure one default route here, right? Or I can advertise only a single route. Or see, by the way, these two are definitely unwanted prefix, guys, right? So how we will filter these prefixes from the routing table of ASA firewall? In the same way, on the core router also I have some unwanted prefix, so IP route, right? So how we can filter those unwanted prefix? Like on distribution layer switch 1 also you can check. So IP route OSPF. So see, unwanted prefixes are like this. Here we don't have any unwanted prefix. I think filtering is there. So IP protocol node set. So IP route OSPF 192.168.0.0/24 is the main subnet 0.0/30. See this network, right? The network subnet which is running between core router and ASA firewall. Why my distribution layer is going to learn this prefix, is going to store this network information in their routing table, because distribution layer switch is not going to forward traffic to this network. And guys, here I have only one segment, but in real time you will have many segments, right? Like let's suppose I have two device at core layer for the redundancy, then maybe you will have 4 subnets there. So how you can filter unwanted prefixes, how we can clear the routing table, how we can improve the configuration, how we can secure this network, everything we are going to discuss in upcoming videos. That's all for today. Now last request to you is, guys, if you have learned something from this video, please hit on like button. If you are new on this channel, please subscribe this channel. We will meet soon in next video. Till then, stay safe. Bye bye. That's all for today. And one more thing, if you want more videos like this, if you want I should complete this playlist as soon as possible, then please type yes in the comment section. Guys, once you will type yes in the comment section, I will get to know that these videos are helpful for you, right? It will motivate me to make more videos. So your yes in the comment section is representing that these type of videos are helpful for you. I should create more videos like this. Okay, now that's all for today. Bye bye.